In this video, we are going to investigate the limit of this function f of x at some point. Alright, so if looking at this function, it looks as if we have two functions on this graph, but this is just one function called f of x, but the thing here is that the function is discontinuous at some point. So look at it here, the function is discontinuous, and at this point as well it's discontinuous. So now let us critically investigate the limits. So for the first one here, I have limit of the function as x approaches 2 from the left. That's why we have 2 negative. Now look at the point 2. Now as we approach 2 from the left, let's say we move this way from the left, approaching 2, let us trace it down because we cannot get directly at 2 because the function might not exist at 2. So getting close to 2, let's trace it upward and see the value we have there. So closer to from the left hand side, we are having a value that is equivalent to 3 on the y-axis. So this is 3. All right, let us investigate as the function approaches 2 from the right. So this is right of 2. So at the right of 2 now, as we approach the right of 2, let us see what we have. It might not be exactly at 2 actually, but very close to 2. We see that the value is equivalent to 1 on the y-axis. So in this case, the left-hand limit is 3, while the right-hand limit is 1. So that actually tells us that the limit does not exist. Because since the left-hand limit at 2 is not equal to the right-hand limit at 2, then that means the limit of the function at 2 does not exist. Does not exist. All right, now let us look at f of 2. F of 2 is actually the real value of the function at 2. Looking at it here, we have an open ball and we have a closed ball. That means for here to be open, what it actually implies is that the function does not have any value here. But here is closed, so that means that the function has a value, and the value the function has at 2 is actually equal to 3. So that's why we claim that f of 2 is 3. Now let us look at the limit of the function at 4. The limit of the function at 4 now is going to exist. And why will it exist? Because if I try to approach 4 from either the left, I'm going to get a value close to this, which can be traced to 4 here on this axis as well. And if I still approach 4 here from the right, I'm still going to get a value which is still going to submerge into that point. So I can see that both the left-hand limit and the right-hand limit at 4 is equal to 4. So because the left-hand limit and the right-hand limit are the same, we see that the limit here exists and is 4. All right, now let us look at f of 4. F of 4 does not exist. F of 4 does not exist. Why is it that f of 4 does not exist? Because the function is open at 4 from what we are seeing on the y-axis. So since the function is open at 4, then we say that f of 4 does not exist. Now, remember that a function is said to be continuous if the limit of the function is equal to the value of the function at that point. Now, if you look at this, the limit is not equal to the value of the function. The limit is 4, but the value of the function does not exist, so there is a discontinuity here. Same here, the limit does not exist, so there is a discontinuity. Thank you very much.